we need to find a family of solutions for 1 plus ex cosine y dy ex is equal to ex over y. So this is a lot we have to do. We then want to find the solution to the initial value problem, so you're going to have to plug this into what we have here. Now to do this, notice that we have this dy dx. And because of this, we can use separable equations. And we want to put everything that has a y on the left-hand side. So we'll multiply both sides by y, and we'll get a y cosine of y. Then we'll have it multiplied by dy, and then move everything with an x onto the other side. So this other side is going to have an e to the x over 1 plus e to the x times dx. Now from here, since we have a dy dx like this, we're going to want to integrate. It's a pretty good sign of integration right there. So we have two sides that we need to work with, right and left. Let's start with the left side first. This one's arguably the harder side because we have to do by parts. So for by parts, we're going to use the formula where we have our u times v. This is going to be our bounds minus the integral of, I think it's like v du. And our u and v's, if you haven't seen this before, is going to be like this. We're going to have a table where we have u, du, v dv, and we're going to set these equal to some things that we're just going to plug in. So looking at our equation right here, we have our y cosine y dy. The simplest thing is typically going to go into our u, so that's going to be a y. We take the derivative of it, and it's going to give us a dy. Now our dv is going to be the cosine y dy. And so now we need to actually take the integral of this to get it back to v, right? So we're doing the opposite here. And this, the integral of cosine, is going to give us a sine y. So it'll look something like this. Because if we take the derivative of sine y, it'll just give us a cosine of y. So now that we have the following, we are going to easily be able to substitute this back in. So we have our y times sine y. We don't have any limiting factors, so we're not going to plug anything in there. We have minus the integral of sine y, and then d should be dy. Now from here, we're just going to keep on going. We have our y sine of y minus, and the integral of our sine of y is just going to give us a negative cosine of y. So since we have a negative cosine, we are just going to make this a plus, and it'll be cosine y. And we can have a plus c here, but since we have more that we're going to do on the other side, we'll omit the plus c for now. So this is going to be the by parts right here, and that is going to replace all of what we have right here. Let's look at our right hand side. We need a u substitution for our denominator. U is equal to 1 plus ex. Du is going to be just equal to ex dx. And so from here, we can plug this back in. We'll take the integral of the entire part. The top part is going to be taken over by this du, and the bottom is just 1 over u. And since we have 1 over u, we know integrating this is going to give us an ln of u. Now u is 1 plus e of x, so really this is just ln 1 plus e of x, like this. And since this is the right hand side, when we plug this back in, it's going to need a plus c as well. So all together, this should look something like y sine of y plus cosine of y is equal to our ln, absolute value 1 plus ex plus c. Now from here is where we're going to want to plug in our values so that we can solve for c. We know our y is pi over 2, so we're going to have a pi over 2. Sine pi over 2 is just going to be 1. Cosine pi over 2 is going to be 0, so we're just left with pi over 2 on this side. And then we have ln. We are going to have 1 plus e to the x. Our x is just 0. Anything to the 0 power is just 1, so this is going to be equal to ln 2 plus c. When we look for our solution, so this is the answer here, we are pretty much going to get y sine y plus cosine of y is equal to ln, absolute value 1 plus e to the x, absolute value, and then we'll have a plus pi over 2 minus ln with 2 in here. We're not going to simplify it. We're just going to leave it like that. You can always simplify it if you want to, but you know, that's pretty good. So that's going to be the answer to this problem. That's how we would find a solution to the initial value problem and the solution for what we have up here.